other samples that you don't really need to spend a lot of time. You can just open one and use it. Now, all of these are built-in samples, so a customer cannot really change it, but he can do a save as, and then he can manipulate it and abuse it. But by default, we give a lot of samples that the customer can use, but cannot change it, so it will keep, he can keep it as a kind of a baseline. Now, application manager is where a client, where a customer actually builds his application. So, enterprise. Earlier, Don was using the enterprise mix. This one. So these are the protocols that are included in this sample mix. Any protocol mix can be weighted by how much bandwidth each protocol consumes or how many users flows are done per protocol. So what I'm going to do now is Superflow is the actual application. So I'm going to build a sample HTTP Superflow, but instead of creating a normal HTTP Superflow will look like that. You know, the client is sending GET, delay if you want, and then the server respond with a response. So this is a normal. Now, in order to create an attack, I don't care about this. I want to send a GET, but I want to repeat this GET message endlessly. I mean, I'm not going to be nice. So I'm going to create a new Superflow, whatever, just give it a name. Between the client and the server, I will select an HTTP. Now, the fun part here is that I can send it not only back-to-back, but I can actually attack any real server, and I can spoof any IP count that I want. So if I'm connecting my device to the internet, I can actually send traffic towards a real service. Not that it's legal, but it's easy and possible. So once you have your HTTP high-level protocol, I can first of all decide that I want to simulate that the header of my GET will look like, I don't like it's coming from Android, HTTP 1.1 or whatever if you wish. You can change the port number and a lot of like global parameters, but this is still on the global level of my protocol. And then once selecting my protocol, I can add commands. So the first command will be HTTP GET. Now we also have other commands that I can use. I can even use the raw data command to create a GET message that doesn't look like a GET message, like a little bit of using the content, so that the server will not only get a GET flag, but the GET flag is malformed. So it's like two issues at the same time. So then I can open the GET message, and now let me try even to increase it. Is it readable? Hope so. So I want to go to this directory, like here sample, and to ask for this file. Okay? Now, if I will ask for this file over and over and over again, it's kind of a static attack. So all the time I'm kind of targeting the same point. Now, if the file exists, I will get a 200 OK. Yes, the file is existing, and please take it from the server. But if the file doesn't exist, I will get a 404. The good part of HTTP, in any case, the server will answer. There is no way that I will send a request to a server and it will say nothing. He must answer by, I don't have it, or I have it, here you go. So because of that, I can actually try to randomize the request. Like BreakingPoint has variables that are really easy to use, like alpha, 3 characters. So you have plenty of, we call it tokens, you have plenty of different tokens that you can use. Alpha, alphanumeric, numeric only, kind of low Indian, bigger Indian, and all kind of stuff you can use to create issues. Now a URI usually starts with a slash, and now like index.html. So the file will be always the same, but the directory location will change every request, just because I want to make it a little bit more fun. Okay? Now the rest of the parameters right now are not important. The only thing I want to make sure it's a GET, and blah, blah, blah. Now, once I have my GET message, I can do 2 different ways of attack. I can send one GET message per TCP connection, like the attack will be a massive amount of TCP connection, and each connection will send one GET. But then the amount of GET messages I can transfer is kind of limited, because I'm I need to follow the performance of my TCP connection rate. So what I can do, I can now look for a command, for a go-to command, and I can ask this go-to command to go back to the get message another, let's say, whatever. Save this profile. Now, in order to use the profile, I must attach it to an application profile. The way Breaking Point works is the test is pointing on profile. Please use this application on this network. You don't set up the IP addresses in the test, and you don't set the application information inside the test. The test is only pointing to the profiles you wish to use. So my application profile is done. I need to attach my superfloat into an application profile. So I will create a new application profile. Nimrod HTTP flood. Okay, I will add my DDoS into my profile. Okay, now because I have only one superflow in my profile, the wait system doesn't have any meaning. So if you wish to send a single application using Breaking Point, either if it's a DDoS or a legitimate application, you can use it, you can do it, and then the wait system, it doesn't have any effect. That's the whole point. So now I can do a test, new test. Let's of course save it. Let's go out so it will be visible. So the Breaking Point default network is a bridge network. Like the IP addresses that we selected are in bridge mode, so the client and the server are on the same domain, so they can talk to each other. The reason that the default is working in such a way, if a customer receives his new Breaking Point and connects a back-to-back cable, any test that he will try to run immediately runs. So he will not call the support and ask, like, I bought a 200K of a system and I don't see any protocol working. So we try to make sure that the first time he will play, he will get some traffic flowing. So I don't need to change the network profile. All I need is to select the application profile, the application engine. Now I'm using the application engine that usually needs to run legitimate traffic, but now I'm using it for my DDoS. So this will be my DDoS HTTP. Now you can use in a single test up to 20 application simulators. So it's really important to give it a name, because then in my report, each application simulator will have its own chapter, so I can analyze it separately. So I can have like one AppSim doing the DDoS and another AppSim doing some normal traffic in the background. And then once I get the report, I can distinguish what was happening with, for each one. So this is my component. I'll configure it. So to configure it, first of all, it will send traffic from port 1 to port 2. I'm not going to do a training today, so I'm not going to speak about the IP and blah, 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 just in general. And then the parameters. So right now it is set to send 10,000 TCP per second. I don't need so many. Why? Because each connection is going to send 10,000 gets. So even if I put here like 100, just to show you, the reason I'm putting here a low value so I can extract a piece of the capture and show you how it actually behaves. Okay? So because if I will send too much traffic, it will be difficult for me to open the capture buffer and show you a sample, because even so our capture buffer is wire speed, try opening a huge amount of data in Wireshark. It doesn't like it. So I will go down, change my application profile to my DDoS. Okay, select it, and go out, save my test. And run it. I hope I still have the ports. Now, usually we use the summary page to follow the information, because on the right hand I have the bandwidth, and as long the bandwidth is TX and RX are equal, 1 second it will. As long as my TX and RX are equal, it means that all my packets that I'm pushing are coming back to my system. Now this is kind of an aggregated transmission of all the ports all together. I mean, if I'm connected to the device using 4 ports, like 2 are clients and 2 are servers, this will summarize all the ports all together, because the concept is, when I'm pushing data into a system, it doesn't matter from which port I send it, it needs to come back. So if I have any delta between the in and out, there is a problem, and I need to identify it. Now you can see that the connection rate, the response time, but it's not really important for me, because now I'm creating kind of a traffic pattern that is not legitimate. So my goal here will not be I mean, if I'm running such a test, my goal is not to see how bad is the delay, but to validate that after a few seconds, let's go back. Once breaking point stopped, you can still go back and see what was the result during the test, if you wish. So after 30 seconds, TX and RX was equal. If there was a DDoS mitigation device, I would expect that the TX will be 1 gig, but the RX will be 0, because everything should be dropped by the device. Okay? Now I can ask to see a small piece of the capture buffer. So this is the perfect storm 1. Packet export, you see I have 4 gig of capture. Now I'm not going to take the full 4 gig, so I can ask to show me a small piece like of, let's say 10 megs. Okay, he's taking it out. And okay. Now, you see the directory name? Randomized. Every time it's a different directory name. So this is what we mean by dynamic content. And it doesn't only go to the attack side. Even the legitimate traffic needs to randomize itself all the time. Now, the good part with breaking point is that I can keep the size, steady, so the bandwidth will be kind of a straight line, but still the content will change. Because a lot of customers, they don't like that the bandwidth deviation goes up and down during the test, because then they cannot really easily calculate the average bandwidth we generate. So I can change the content, but keep the transaction size. Of course, I can do the opposite as well. I can randomize the content anything between like 3 to 30, and then the bandwidth will start to go up and down. Now, if I will follow any TCP connection, let's hope I will take one that is. You will see multiple gates running, and each one has a different value inside. This is just a single connection. Okay? And it took me less than 2 minutes to build it. And if there was a device in the middle, like less than 10 minutes to show his maximum performance under such conditions. Now the next level, when I'm running, or when we do such event, a professional services event or a test event, will be to go back to my test, add another component, another upsync, call it my legit. Okay? So now I have one is sending the attack, the other one is doing legitimate traffic. First of all, for the attack, let's just make it shorter so I can run a very, very short test so I can show you the report. So load profile. The test right now will run for 60 seconds. I will take it down to like 20 seconds. Okay? 20 seconds of an attack. No rundown, because when you send an attack, you don't need to be nice. You don't need to run down nicely. If the connection stays open, I don't care. It's the problem of the device on the test. I mean, for the legitimate traffic, I like to close all the connection properly and to be very nice, like a normal PC. But for my attack, who cares? I mean, if I manage to kill a device, I won, so I don't really care how. So I go out. Now, because this attack is 20 seconds, I can ask BreakingPoint to start sending the attack only after 10 seconds. So the first 10 seconds of the test will be only good traffic, and after 10 seconds, he will add my DDoS. And now I will go to my second component. Now, both components will use the same IP range. So the attack is kind of integrated from the same source domain to the same destination domain. Because in some DDoS scenarios, the customer will ask you, I want to send an attack from the same domain, like someone from inside my network is sending an attack, or someone outside my network is sending an attack. And we can simulate these different situations. So next, this is my legit traffic. So I can leave the default BreakingPoint bandwidth protocol mix, I don't really care. It will start immediately. I will again reduce the load so it will be easy to see what's going on. And on the load profile, the other one was sending an attack for 20 seconds, so this one should go for 40 seconds, like 10 seconds before, and then to continue sending traffic during the attack. I don't really need a rundown because there is no device in the middle, so it should be able to close all the connection immediately. BreakingPoint is very powerful, so BreakingPoint is actually capable of closing all the connections that he managed to open during the test in 1 second. It doesn't need a lot of time. The reason that we give it more time than 1 second is that real devices don't appreciate 1 second drop down. It's too fast. So, I have my legit side, I have my DDoS configured, these two components, and now I can run the test.
Look how many IP addresses are being used.
Now you are...
It says 131,000 IP addresses are being used. So you can see how fast it's initializing 131,000.
I can increase it to 10 million and be the same.
Yeah, but it's amazing how fast it can spin up those.
So the test started. Right now you can see only the legit side. So the legit traffic is about 200 megs. Of course, when I'm doing a real event, I will ask the customer what he expects. I mean, what is the size of his organization? And we try to kind of mimic his normal traffic behavior. And once the traffic shaped like his organization real situation, then I will start injecting my attack. So now you can see the attack is flowing as well. So from 200, I jump to 1 gig.2. So we have both the attack and the legitimate traffic. Here I can follow up with my schedule. So after 40 seconds, the test needs to finish. Once the test will end.
I guess why I brought up the number of IP addresses was, so what's the alternative? Right? What's the alternative to doing it? You would say, well, I'll spin up a bunch of VMs and run an attack inside, right? Well, how do you spin up 131,000 VMs at the same time? It's just impossible.
And as far as we know, Avalanche has some IP range limitations, by the way. I mean, Avalanche as a software-based solution doesn't appreciate too many IP addresses. So once the test finished, I can open the final report. And this one is a little bit small, so it might be hard to read. But for each component now, I have a chapter. So I can analyze my DDoS traffic separately and my legit separately. So I can see over time the throughput that was sent by my DDoS attack. And at the same time, I can go to my legit traffic profile. I can first of all analyze the application to see that there was no application failures. And I can also check my application's throughput to see that there was no degradation. I mean, if there was a real device, during an attack, it takes like about 5 to 20 seconds to detect and to block an attack. During this 5 to 20 seconds, I should expect a bandwidth drop down because the legitimate traffic will not be able to flow as usual. And I can measure how much time it took and what was the effect. How much, I mean, in terms of percentage, what was the drop down, of my legit users? Or what was the effect on their response time? Because this is how I will feel it in a real situation. And that's what we try to deliver. Okay? And that was like 5 seconds on DDoS attack using BreakingPoint.